Okay, so working with more with fractions that have got equations as their denominator or a numerator. Sometimes we are given more than one equation of this type. We have to add them together or deduct them. Although we can't find the answer, we have to put it so that they're just one equation. So this is an example by here. Both the numerator and the denominator are equations, or formula, I should say. On the left, we've got 3x plus 1 over x plus 2. The numerator is 3x plus 1. The denominator is x plus 2. Take away x minus 2 over x minus 1. The numerator is x minus 2. The denominator is x minus 1. Now, we don't want this to be two separate fractions. We want it all to be one formula over another formula. So how do we go about doing it? Well, if you remember with fractions, if the denominator is different, and the denominator is different by here, it's x plus 2 with one fraction and x minus 1 with the other one, then we used to multiply it by the denominator of the other fraction with that fraction, that denominator, as the numerator and the denominator. So for instance, if you had 2 over 3 here and 1 over 5, I'd multiply this one by 5 over 5 and this one by 3 over 3. In this case, we haven't got numbers, we've got equations, fractions, a formula, sorry. So the denominator to this one is x plus 2, so I multiply this fraction by x plus 2 over x plus 2. And with this one, the denominator, sorry, this one over here, the denominator is x minus 1. So I multiply this one by x minus 1 over x minus 1. So what is the point in doing this? Well, exactly the same point as doing it with the fractions, because this is fractions, remember. Just because they look nice with a lovely number on top and a number on the bottom when we were working with them in fractions a long time ago, they're still fractions, just the denominator and numerator are represented by formula. So by doing this, when we multiply the tops and the bottoms, as we do when multiplying fractions together, the denominator will become the same, and then we can put it all over the same denominator. Let's have a look to see what I mean by that. Well, this is going to become 3x, because we multiply the tops and we multiply the bottoms when we multiply in two fractions. We're going to multiply this 3x plus 1 times x plus 1 minus 1, and the bottom is going to be x plus 2 times x minus 1. Notice how I put them into brackets, because then when the brackets are next to each other, it represents the fact that we're multiplying the two formula together. Similarly over here, it's going to be x minus 2 times x plus 2 over x minus 1 times x plus 2. So let's start with the top left. Now we've got a little equation we have to multiply. We're going to use FOIL. So first is going to be 3x times x gives us 3x squared. Outside it's going to 3x times minus 1 is minus 3x. Inside is 1 times x, which is x. Last is 1 times minus 1, which gives us minus 1. Put them all together on top, and then we can simplify because minus 3x plus x is minus 2x. If that was too quick for you, go back and have a look at the FOIL video, because I don't explain that in detail again when you can watch that video. We're on to more complicated things now. And remember that the more complicated work will always incorporate the easier work, which incorporates the work that's easier than that again, and so on. So you must be clear with the other videos before moving on. So now you can see, instead of the two brackets multiplying each other, we've got a nice crisp equation on top, 3x squared minus 2x minus 1. Okay, so next let's work on the bottom equation. So x times x, the first, gives us x squared. X times minus 1, x times 2, I've actually done the, is 2x. So I'm working on the top right here. X times minus 2, the insides gives us minus 2x, and x times 2 times minus 2, gives us minus 4. So with the top equation on the right side, we're going to put all these together and swap. So we swap those two lots of brackets for these, and we can simplify because minus 2x plus 2x cancel, leaving us with x squared minus 4. So again, you can see we've changed it from these two lots of brackets into a nice equation. Now, because the bottoms are both the same, remember it doesn't matter which way around the brackets are, you're still multiplying x plus 2 by x minus 1. Because they're both the same then, we only have to work out one of them and we can change both of them into the same value. So the first will be x times x. The outsides are going to be x times minus 1, minus 1x. The insides are going to be 2 times x, 2x. And the lasts are going to be 2 times minus 1. So we can swap both of those sets of brackets for all these lined up and then simplify, because 2x minus x is x. So now you can notice that the denominators are actually the same. X squared plus x minus 2. And that was the whole point of doing that process. We have to make the denominators the same on the fraction. So can you think why? Well, back in some of the first videos we did when we studied fractions, if the denominators are the same and you were adding them together, then you just add the numerators. Similarly, if the denominators are the same when you were subtracting, you just took the numerator off. So for instance, if I had 2 over 3 plus 1 over 3, it's 3 over 3. Or 3 over 4, take away 1 over 4, is 2 over 4. So in this case, we just put the same denominator and take away the right numerator from the left numerator. So let's put that together. So you'll notice how first of all I've put a bracket around this. You'll see why I've done that in a second. We've crammed it all onto one. It's all on top of the line now as the whole numerator and just one denominator. Now, the reason why I put the brackets is because we're taking away, it doesn't matter so much if it's a positive and we're adding the other one, but if we're taking away, we've got to remember that although we take away the x squared, we were taking away minus 4 as well. And taking away a minus means we're adding it on. So 2x squared minus 2x minus 1 plus 4. I've just simplified it down. Simplify it down again, and there you go. That's as far as we can go with simplifying that. But we've done what the question asked. We've simplified it down into a single equation.